Hi, and welcome to Chapter 7. In Chapter 7, we get to introduce the concept of lists. Lists and tuples are ways that we hold lots of data in a collection, in a group, so that we can iterate over it and keep things straight. Let's get started. So the first thing that we're going to cover is the concept of a sequence. A sequence is just an overall encapsulating word that we use to describe things like lists. And you've seen lists before. We've done them actually when we were doing for loops and doing things in a range so that we could loop over things. So we had the option of a list like that. We're going to do the same thing, but we're just going to get into more of how to use those lists throughout Python and in different ways of programming. So a sequence, by definition, just refers to any object that holds multiple items. And it holds them one after another. So they're all kind of lined up. And we can do things with the fact that they're lined up, like walk through them, or change the order, or reference them by a specific order. If you know of any other programming languages, if you've already done that, lists and arrays are essentially the same kind of thing. So in Python, we call them a list. In other languages, they're called arrays. But they do the same thing. They hold multiple items. In Python, we're going to use lists almost exclusively for now. We will get into dictionaries and a couple of other things a little later on. But for right now, we're just going to be referring to lists. And a tuple is a type of list, which we'll get into at the end of this chapter. Lists, by definition, are mutable, which means they're able to be mutated, they're able to be changed. So when we talk about mutable, obviously the opposite of that is available, immutable, but lists are mutable, which means they can be changed. We can create a list and then we can modify the values that are in that list and change them around. We can sort the list, we can pull things out, put things in specific places. So the fact that it is mutable means that it is able to be changed. I always like to think of it as mutate. It can be mutated. So the big thing about lists is that they're mutable. When we get into tuples, you'll understand the difference. So when you're making a list the first time, you're going to create a variable and you can set it equal to a list. There are 4 different ways that we're going to talk about making your list. You can simply create it by having the items one by one. So I can put a bracket and then put 1, 2, 3, 4, 5 and put those inside of a list that's going to hold those 5 items. The thing about Python lists is that they do not have to all be the same data type. In certain languages they do, but in Python they don't. So I can have a list that holds an integer and then a string and then a float and then a boolean, and that's fine. You're allowed to have multiple data types in a single list. You do not have to keep them all one data type. Again, different languages you do. Python you don't. In Python we can put anything we want in a list. There is a method called list that you can put things in similar to our range that we have talked about for our for loops and being able to iterate over items. So if I wanted to create a list from 1 to 100, I could use the range method to be able to create my list using that. So I would use the list keyword, it's a function with open and close parentheses, and then inside of that I would pass in a range function with either the start, the end, the iteration. Remember, we've talked about range, different ways that you can make your range. In this case, I've simply put a range of 3, which puts in 0, 1, and 2 as my values. The last way of creating a list is using our repetition operator, which is a star or a multiplication symbol. And this is going to create whatever list you've defined multiplied by itself. So in this case, if I wanted to make 1, 2, 3, 1, 2, 3, 1, 2, 3, I can take the list of 1, 2, 3 and multiply it by 3 to create a list that duplicates that 1, 2, 3 3 times. If I wanted the same value in the list, I could put a brackets and just put 1 and then put the repetition operator with a star and put 10, and I would put 10 ones all in a row. So if you wanted to create a list that was all the same value, using your repetition operator is a great way to do that. All right, so now we have created our list. Now we want to do something with it. We want to use our list, and there's a couple of different ways that you can do that. The first is that you can iterate over a list using the for loop operator. So the same way that we've already done this, you've seen us using the for operator with a list. This is another way of doing it. So if we have our list as a variable, in this case I've created a list called numbers, and I've added a bunch of numbers to it, and now I can iterate over those numbers. And I can say for n in numbers, and the n will then be populated each loop with the first second, third, and fourth number out of that list. So you can iterate over them using the for loop. You can reference an individual index in your list. So if I wanted to get the second item in my list, I could say list and then put in a 2 for the index in between brackets, and that will reference the second value in a list. It's really important to remember lists are 0 based, which means our index 0 is our first item. Our index 1 is actually our second item. Our index 2 is our third item. So referencing the index of your list, remember that it's starting from 0. The other thing we can do is we can find out how long our list is using the length operator, or len, or length, to figure out how long your list is. And we'll use this sometimes when we want to iterate over the entire list, but we don't want to just use the basic for loop, but we want to know what the length of it is. So I can use the length operator, the len, to find out how long my list is. Remember, lists are mutable, which means they can be changed. I can add things to it and remove things. So even if I created my list with 5 items to begin with, I don't know that it's always going to have 5 items. It might have 10 by the time that I get hold of it because of the way that I can change it. Another thing about lists that you can do is you can use the print operator, or the print function, on your list, and it will print out your list, and it'll put brackets around it because that's the notation we use to define it as a list. So putting brackets around it is the notation that will come out when you say print with just the function or the variable name for your list. If you want to print each of the individual items of your list, you're going to have to use some semblance of a for loop and print the way we did at the top of this. Another thing that we can do with lists is we can concatenate them together. We can join them together. The joining operation, the concatenation operation for lists, is just a plus sign. We can take 2 lists, the way I've done here with numbers and numbers 2, where I can add the 2 lists together and create one list that holds all of the values. Okay, so these are a couple of different things that you can do with your list once you get a hold of it. When we have our list, sometimes you want to slice it and you want to get a subset of your list. Sometimes it's from the front to the middle. Sometimes it's from the middle to the back. Sometimes it's the 3 items that exist in the middle going 3 items in and 3 items from the back. So splicing or slicing our list is something that we can do. When we reference our list, remember, if we just want the second index, we can just do my list and then brackets and then 2. But if we want to slice it, we want to create a sub list of just sections of it, we can create it by using kind of the same notation that we did for our range. The first number is going to be your starting place, this with a colon, and then your second number is your ending. And then your third, if you want to have one, will be your step or your increment in between each value. You don't have to have that one. The same way that you really don't have to have the first or the second. It's kind of an either or. If I want to start from the beginning, I just leave that blank. So I do a bracket and then a colon. So I leave the space blank where the start would go and put 5. So I would get from 0 to 5. If I want to go from the second index to the end, I leave the ending space blank. So 2 colon and then just leave the place where the end would go blank. If I do not want a step, I just don't put one in. But if I want a step, it goes after the second colon that comes after the end. So if I wanted to do from the first to the end, stepped by 3, I could go colon, colon, and then 3. So the notation is simply start colon, end colon, step, but the default values for each of those exist. So if I did nothing, so if I just did colon, colon, that would start from 0, go to the end, and step by 1, because that's the default step value. So the default start is 0, the default end is your length, and the default step value is 1. You can change these around to get pieces of information as you want them. And remember, you can always reference an individual item from your list by just putting that number in the brackets. There's a lot of methods and operators that we can use with our list. I'm only going to reference a few of them that you're going to need. But if you look in the Python documentation, you'll see that there's a lot more that we can do with a list. The first one is to find out if a value exists in a list. And this is going to be useful in your homework, where you're going to have to find out whether or not something exists in your list. I need to go find something, searching. You can use the in operator to be able to say if this value is in my list. If it's in my list, then do something. If it's not in my list, do something else. So I can make that a Boolean choice of is this item variable, whatever it is, does it exist in my list? So that's the in method or operator. We can use an append where it adds an item to the end. When we append to something, we add to the end of the list. We can return the index number of a specific item. So if I have a list of 100 numbers and I want to know which index number 15 is in, I can say index of 15 and it will return what index in my list that is. I might need to know where it exists in my list for a purpose. You can insert into a specific index. So if I said I wanted to insert into the index of 4, if assuming that my list is more than 4, it will take everything after 4 and kind of push it over and push in that new value into the 4th index. Everything else gets pushed up 1. So it readjusts or reallocates your list after you've inserted 1. You can sort your list. Sort works just by default. We can talk about sorting algorithms and other ways of handling sort later, but for right now, sort just will automatically do ascending order of the items in your list. You don't have to give it any parameters. You just say mylist.sort and it'll sort it for you. We can remove an individual item from our list. So remove item, it'll go through your list, find that item and pull it out, and then again, reorder the remaining items. We can reverse the order of our list. So if I've created my list 1, 2, 3, 4, 5, and I want it to be 5, 4, 3, 2, 1, I can call reverse. It's also an easy way of sorting by descending value. So backwards, you can sort by ascending value and then reverse your list. That'll flip it. We can delete the item that exists in a certain index. So remove removes the item. Delete removes the index. So if we have something in index 4 that we want to get rid of, we can just say delete the index at index 4. Everything gets reallocated and that item goes away. Doesn't matter what the item was. And the last one on this list is your min and max. We can just quickly find out what is the minimum or the maximum value that's in your list. Remember, strings also have a value. Remember our ASCII numbers where 65 is a capital A, 97 is a lowercase a. All of our strings have a numeric value and therefore can be sorted and can have mins and maxes. So mins and max doesn't just apply to numbers, it also can apply to strings. So that's your min and max. So these are just a couple of the operators that you can do on lists to be able to manipulate your data once you're in there. I'd like you to take a few minutes now to go do the project that's in the book, chapter or program 7-12, which is on page 370. You're going to go ahead and get the student test scores, calculate the total of the scores, then you're going to subtract the lowest because the instructor is nice enough to remove the lowest grade. Figure out the adjusted total and find out what the adjusted average is and print it out. So this is going to give you a chance to start entering information into a list because you won't know ahead of time how many items are in that test, how many test scores you're going to be using. So you're going to be adding things to a list and then being able to calculate some information on those lists. Hopefully this will give you a little bit of example on how to use lists before you start working on your homework. For the purposes of your homework, you're going to have to read in from a file and insert something into a list. To do that, I've given you examples that came straight out of the book, so you can reference them there as well, both for reading items that are in a file and putting them into a list, and writing items from a list into a file. So a little bit of the backwards. So the first one, the one over on the left, is the writing lines. We can create our list, and we can simply use our file and say write lines, and plop our list right in there. And it'll go ahead and insert those with the new line character already in there, and it'll put the whole thing into a nice little file for you. With the reading the lines, we have to open up our file and we have to read those lines. But you can use the methods here to be able to get all of those lines as a list, and then be able to go through that list with a while loop to find out what each of the individual items are. So these are just two different ways that you can deal with files and lists. Again, in your homework, you're going to have to do some stuff with lists. So this is kind of a good example. You want to go find this in the book and reference it if you're having any trouble. All right. One of the special kind of lists that we can create are two-dimensional lists. I sometimes refer to them as matrices or matrices. Um, you can kind of think of them as a spreadsheet or a rows and columns list of items. So for each row, you have multiple columns. The same way in a two-dimensional list, each item in your list is a row, and each row holds a list, which would be the columns that exist in that list. So we can create a two-dimensional list, kind of like a matrix 4x3 list, where you can hold different pieces of information. The example that again came out of the book here was using a nested for loop to put values into a list. You can also use a nested for loop to pull values out of a two-dimensional list. So this two-dimensional list, you can think of it as my list, and then with your brackets, you would just have two sets of square brackets, one for your rows, one for your columns, and that would be able to get you the value that exists in that location. Okay, so these are two-dimensional lists. We don't do a whole lot of them in this class, but it is something I want you to recognize is an option, especially if you ever end up in a situation where you need a two-dimensional list, you know that you can do that. And the last part of this chapter gets into the concept of tuples. We mentioned tuples at the beginning. The difference between a tuple and a list is simply that a tuple is a list that is immutable. It cannot be changed. You might think, why would I want that? So a tuple can do everything that a list can do, except it can't append, remove, insert, reverse, or sort. It can't change. It has to be the same way that it was created. You can't add anything to it. You can't take anything away. You can't reorder it. And you may be thinking, why would I want to do this? Well, first off, your performance is 100 times better when you use a tuple instead of a list, because the compiler doesn't need to keep track of allowing you to change things. It doesn't have to store things. It's not 100 times better, but it is better. So the performance is better with a tuple than it is with a list. Also, you can be sure that your data is consistent, that you know it can't change. You couldn't have written any code that made it change because tuples can't change. So when you create a tuple instead of a list, it's just an immutable version of a list. So you can be sure if you're using a constant or any type of value for that, that you want to make sure that that value doesn't change. You can use a tuple for that instead of a list. All right, I am going to add a slide here for essentially the turtle graphics or the graphics version. I usually skip this because I let you guys figure that part out on your own. But this one's using the plotting library that allows you to plot graphs. So we've been working with the turtle a lot, and this is similar to that in the fact that you're going to have to import the plot library and then use that, the methods that exist in there, and it'll pop up just like the turtle pops up. In your homework, we are going to do one of the projects with Matplot library. Generally, this does not get installed automatically with the Python install. You have to go get it. So to do that, if you have a Windows machine, you're going to open up a command prompt. So you can go to the search and you can type in command, get a command prompt, and just type in pip install matplotlib. And that's the library that we need to get. It'll go ahead and run through the installer, get everything put in the right place, and then you should be able to reference it the same way you normally do in your VS Code. If you have a Mac or a Linux machine, the instructions are also in your book on how to do this under this chapter. So that'll help you to kind of get those installed. I'm just going to assume that everyone has a Windows machine. Once you have installed it, you can go ahead and import it. And what we like to do generally with this one is we import it, and then we import matplotlib dot, and then the pyplot or the Python plot. And we store it as something like PLT. The reason we do this is because we don't want to have to keep referencing matplotlib dot every time we want to do that. So this way we can just reference PLT, and we can use all the methods that come right off of that just directly. When you do a plot, in this case we're doing a line plot, so a line chart or a line graph, and we're going to be giving it our X and Y coordinates. So when you're thinking about a chart, you can think of it as you have X and Y coordinates of where each of the different points are, and then it's going to connect those points. In this case, we are going to put those points into a list. So we're going to have a list of our X coordinates and a list of our Y coordinates. We're going to plop those in, and then don't forget to tell your plot to actually show. And you should be able to do this as soon as it's installed correctly. It's like 3 lines of code, 5 lines of code. It's pretty easy. And one of your homework assignments is similar to this. So have fun with that one. Okay, so for your homework, don't forget to do the Chapter 7 quiz. Um, After that, there are 5 exam exercises. The first one is the rainfall statistics, which is number 3. You are going to make a function. Remember, we did functions, so you know how to make functions. And it's going to take a list as a parameter, and it's going to display the statistics that go along with it. So read the directions in the book. You're going to include a test list for the purposes of this. So not only do I want you to create that function, which I'm grading you on, but I want you to include your test list so I know that you created one. Again, this is in your assignment or in the book, so you should be able to see it there as well. Number 7 is the driver's license exam. So by this point, all of you have probably taken the driver's license exam. There's a series of letters that are A, B, C, or D because it's a multiple choice test, and you can only get, I think it's 6 right or 6 wrong or something like that. So in this case, you are going to read in your student answers from a file. So you're going to have to create a file. You're going to make it a text file. You're going to have to read it in. So I'm practicing whether or not you can read from a file. You should be able to do that. They have given you the answer key in the book. So you're going to create a list that is the answer key, and then you're going to read in the file and find out how many they got right and how many they got wrong. You're going to print out what their score was and then the ones that they missed. Let them know whether they passed or not. So you're going to end up with your list of what the actual answer key was and the list that came out of the file, and you're going to have to compare those two. Number 9 is population data. Number 9 and number 10 are both similar in that they will both require a data file that comes off of D2L. So I included all the data files in there, so you could go in there and download that data file. You don't have to make your own, it's already in there. But you are going to read in that file and then display pieces of information, statistics about either the population or the World Series winners. So 9 and 10 are very similar. Number 14 uses that matplotlib to create a pie chart. So the pie chart is on page 397 of your textbook. If you want to see how they did it, it's a specific type of plot that you're going to use, and then you have to give it pieces of information for it to know how to populate that. So you're going to have your user enter in the numbers for their common expenses, like a budgeting system, and then you're going to pie chart out what that is. So there is no correct answer in this because your users are going to be entering the values in as they go along. And so everybody's just going to be a little bit different. So those are your homeworks for number 7, chapter 7. After chapter 7, you're going to start working on your midterm, and the midterm descriptions I'm going to go ahead and open up on Monday or Tuesday so that you don't start on them until after chapter 7 is done, but it is going to take you a little bit of time. It's going to be a game. Hopefully you have some fun with it. So if you have any questions this week, please give me a call, send me a comment on chats, on Teams, and have a fabulous week.